So I also have a similar question. So this kind of oscillation has been observed by experimentally.
No, experimentally, this molecule has not been synthesized.
Yes.
Successfully yet. So it's not possible from this unless you synthesize.
So what do you show here? The oscillation you have is just
so it's a prediction for the future experimental works.
Evidence. I see.
Yeah.
Okay.
But we successfully predict the electronic property. There's a recent Nature paper for this molecule, triangle paper, and we predict it's a molecule with diradical correctly, and it's published in this paper. And so it's theoretical predict in advance earlier than experimental measurement.
Yeah. In physics, as long as you have oscillation, that's very useful. Yeah, that's very interesting. Yeah.
Any more? Jun-Wei?
In your approach, is the shape of the molecule a result of your calculation, or it has to be an input?
In the input we only have the type of nucleus and the number of electrons, and the geometry can be obtained self-consistently with tau DLT. Okay. So we can predict the geometry and evaluate the energy.
So if in the ribbon type of structure?
Yeah, we obtain the optimal geometry for the 100 AC. Goes up to 100, and I put the geometry on my website.
Do you know whether it's a plane-like structure or
it's a plane-like structure? I think it probably will be curved when there are other agents around. But in this calculation, it's an isolated system with only one molecule, and the predicted structure is planar structure.
I didn't understand much out of your talk, but it was a very nice talk. No, because this is an area that I think, I don't know what you think, this area is a bit remote.
Yeah.
But it was nice and interesting. So what confuses me in your presentation, you have this fictitious temperature theta that enters there, and you are basically calibrating it with exact calculations and all these data comparisons, and then you make predictions, right? What confuses me here is, are you sure this is not? I mean, I'm sure I'm wrong in what I'm saying. Are you sure this is not?
I know what you want to ask, but I answer your question in this slide.
No. I mean, is this a parameter for me? Maybe what you're doing. You know, I will go now to I will play the bad guy.
I know what you are gonna ask, but I answered in this slide because I show you the experimental result and the high level and initial result and the image. Well, even with theta equal to 7 being constant. Yeah, that's your question.
No, my question is almost. My question is maybe you have found a way to improve the KS, the current theoretical. The current calculation, the current equations, which we have a method that you added more parameters, physically motivated, and you have done your calibration. But I'm missing a little bit from your talk. I didn't understand very well the physics of that.
Oh, the physics. Actually, the central idea is the representation of the density. That's the main idea. So we argue the density is a fundamental important because the D is for density,
right.
And we want to simulate the exact this representation with this natural orbital occupation number by choosing the theta, so it simulates this, right? And this is our conjecture. So this is also a central idea in tau DLT, and we verify this conjecture with numerical calculations.
Mm-hmm.
Yeah.
So the theta is actually the parameter you want to tune.
No, we haven't tuned it, but we verify this conjecture because this is physics, right? Because for like statistical mechanics or quantum mechanics, we always have some kind of assumption, postulate or conjecture, and this is the conjecture in tau DLT. Then we verify this conjecture with various numerical results to verify this is maybe correct. Yeah.
But the theta is fixed, or how do you know for a
No.
future application or prediction? How do you know that the theta, the optimum theta, may be 25? I don't know.
Okay, that's a good question. So as shown in this slide, the theta should be related to the distribution of NO, and now we are actually working. We already have some kind of idea how this should be defined.
Okay.
Yeah.
Thank you.
Because for system with for single reference system, the theta should reduce to 0. And for multi-reference system, the theta should be related to the orbital energy and their occupation number.
So if you fix this,
So if we can write theta
Yeah.
as a function of Fi and the orbital, then that can fix
Yeah.
this problem.
Anyone?
Too long.
Okay, so if not, let's send Jeng-Da again.